Alright, hi. So now to the fun part, let's implement things. And so last time we wrote already the segments from Whisper to disk and also here pyannote results to disk. Let's use that as a starting point so that we don't need to run the model again. I probably need to import pandas as PD. Okay, and now I can read CSV, the segmentation df, but and let's call this just so here is the text Whisper output CSV. Need to also then check whether we should read in the index or not that we get, and then the speaker df, and here we read in the pyannote output. Let's look at both. Okay, here basically we have the text and we get another index. This was the original index, but I think that should be somehow consistent with how we did it here. Okay, that's not ideal. Okay, because we did write the index true. Not fully sure that makes sense, but okay, we'll clean that up later on. So here we could drop the first column, but also we could just not care. And here we'll need which columns, start and text, and probably ID, and that should be fine. Okay, so text df, let's keep it small and simple. We'll only use start and text. Nice auto completion. And speaker df, we'll just use start and index. So we could have also just taken kind of from column, this is the 0 column because Python starts 0 indexing, from column 1 to end, but this is obviously less robust than if you really use the column names, because then you don't need to care about in which order they are written or whether this was written to disk or not, like index true or not. And yeah. Okay, so now let's find out for every speaker segment the overlapping text parts. Okay, so let's start with speaker df and look at the indices. This is okay, just regular indices. We could iterate over those, take the first one. Okay, for this speaker segment in we could just also iterate over the rows, I would say. I always need to look it up. So pandas iter rows. Okay, not super meaningful. I think it's something like index this row, speaker df, iter rows, break, then we can check index is really the first component and row is all the entries. So we need to get this start is equal to this row start, and this end is equal to this row end. And let's also quickly get the speaker. Okay, And now I need to check for this start and this end which text could be overlapping. And basically, if there is a text that has, let's look at this text here. If the end point is before the start point of our interval, then there cannot be any overlap. And here, if kind of the start point is after our end point, then there can be no overlap. Okay. So text df. Sorry, I need to always see what I'm coding. Okay. If the text df end is before the start, is smaller than this start, or I think or is like that, or that's nice. Does it work? So the start is after the end, then this is what we should not take. Okay. So no. So this is basically now I kind of just evaluated this, so we see it for the last speaker segment, and there we have okay. So what is a bit weird already is that the last two text components will not get picked. Let's look at them. I loved your first book, so on behalf of everyone. And let's look at the last speaker df, or the last two. Okay, kind of the last speaker stops before those two text components. That's not ideal. Not sure whether it's a bit of a problem because we cropped the audio file, but we should keep that in mind. But kind of the simple way to do it would be we then decide to extend just to the last speaker, but I mean that also might be wrong. Okay. But anyways, like this, how can I prove to you? The text df tail 4. Okay, so we are looking at the last speaker, which starts at 194. So this is strictly before, and this will have an overlap, and this will start strictly after. So this is what we want to have. So we get all text segments with an overlap, and we now should keep track of those text segments. So text df at the location where there is an overlap. And this overlap texts. So let's take them, but let's also keep track at for which speaker was there an overlap. So speaker start was this start, speaker end was this end, and speaker was actually this speaker. And there's a problem. Speaker end and overlap list, and so we can keep track of it. Overlap list, we append this overlap texts and all overlaps plus pt concat overlap list. Yeah. Okay, so we have the so we have the speaker. I think we should probably keep track of the index as well. So there's like in the beginning there's a rather long monologue, and basically, so that's not the best example here to double check it. But now for every text in here, we see with which speaker did it overlap, and we also can compare then and compute how much overlap was there. And in case that a certain text segment will overlap with two speakers, then we would get the same, like in the next row, we get the same start, end, and text, but then mixed with a different speaker start and different speaker end and different speaker. And now we can add a column where we compute the overlap. And then I need to think about whether we will need also to have somewhere the indices. Based on this table, let's say we have this entry once with speaker 00 and another time we have it with speaker 01, and we have the durations, the overlap durations, then I could group by each text. So I probably would prefer to have the text ID, like the index of the text in there. Okay, we dropped it already here. What was the original? Okay, we should keep the ID. Then it's a cleaner column to do a group by operation on. So like if you do a group by, you need to make a lookup in the background and compare kind of entries. And I mean, not an expert here, but I have the feeling it's easier to compare like indexed numbers than like double checking whether this text is the same as a different text. So we should not group by that. Grouping by the start and end time might have been possible as well, but I just prefer it that way. It's a bit cleaner. Okay, let's execute everything. Now hopefully we do have that column. So we have the ID column. So now what we do is for each entry, we compute the duration. So to compute the overlap, I'll take the bigger one of this and this. Let's not make a for loop. Always try to avoid for loops. So all overlaps max start equals, okay, not sure whether it works to apply here a numpy maximum. We will find out. So the max start is numpy maximum, and I hope it does it element wise for two columns, not fully sure. So we take the all overlaps start and all, let's move to the next line, all overlaps speaker start. So this is the first point in time kind of where we could have an overlap. Let's double check whether it works. So all overlaps head for. Okay, so the start and speaker start should be mapped to 5.7 and here it should be mapped to 10.24, so that works. We get also the min end, so the earliest endpoint where there could be an overlap, and then all overlaps overlap duration equals all overlaps min and minus max start. Alright, let's give it a try. So what's the overlap here? It's basically, it could have been 10 seconds, but here it only starts after 5 seconds, so the overlap should be, that's wrong, because we need to take the minimum. Okay, yeah, so the overlap could have been here 10 seconds roughly, but it only starts after 5 seconds here, so the overlap can only be 5 seconds. Okay, and now, so kind of, this is compute overlap durations, this is find overlapping speakers for each text segment, and now pick only one text / speaker combination for each text. So kind of the idea is every text can only be set by one person. So that's it. So all overlaps, we need to group by our ID column. So, and then I think there's something like arc. So I don't need to get the maximum, but the entry of, like the index of the entry with the maximum. So this should be index max probably. Let's do it anyway. So we need to also double check what we are doing. Group by ID count. Let's first see whether there are some. Okay, here you see a number 2. So basically there is a ID which has 2 speakers. And so we group by ID and speaker, count the speaker, and now we'll sort values with regards to speaker, and then look at the tail. How is it called? Okay, it's only a series, so I don't need to give it any name anymore. And okay, so we see that, okay, that's a bit weird. So I think it would mean that our text segment number 34 is associated with 4 speakers. So let's find that and double check. Query ID equals what was it? 34. Okay, it's associated with that speaker, that speaker, that speaker again, and that speaker. Okay, it's probably because we have an overlap of both speakers, and kind of in the middle of that is kind of where this text ends. Okay, yeah, never mind. I mean, let's just do something about it and then afterwards check whether the model or the logic actually is good or not. Okay, so if I get the index max, then I need to also say which is the column where we are looking for the maximum value, and that should be the overlap duration. So now I get the indices and let's see whether we can see that 34 entry. Not sure, it somehow feels wrong. So for every ID, I take the row ID, and this is a bit of a problem because we kind of have multiple times the same row ID. Okay, I need to quickly think about it. So kind of we iterate over the rows and then add some additional entries and kind of add it to the list. But if a row gets added multiple times because it has a overlap with multiple segments, then you always get also the same index, because basically the original data frame, and you pick rows out of the data frame, and sometimes you take a given row multiple times. So I think it should work if we just reset index and drop kind of the original. So then we can compute again the overlaps, and now let's see. Okay, so again, let's look at the overlaps. Query ID equals 34. Okay, still didn't solve the problem. Why do I have that here? Let's look at the all overlaps. That's a bit surprising. Ah, okay. Now again, sorry for that. All overlaps, query ID equals 34. Perfect. So I have the ID 34, but it kind of relates to multiple different indices in the data frame. And now if I just take the index max, then I can see that for 34 from all these columns it picks, no sorry, it's the other way around. For 34 it picks 39, which kind of does seem to make sense. So I get the the max overlap indices, and with those I need now all overlaps at max overlap indices. That should be our final result. So let's see, kind of the ID 34 is now matched to just one speaker, and I hope, was it this one? Yeah. Okay, so that would be our model. So now we have kind of text and speaker always aligned, and what is still a bit ugly is that kind of we should somehow combine those rows where the speaker does not switch. So I think let's try to combine them. Let's also get then the text together, and then we would be more or less done, I think. Okay, quick break, and next time we'll do that. Yeah.